Hi guys, so today we're gonna go over lecture 20. We're gonna be looking at transformation of functions, how different functions move, which way they move, how they move, and we're also going to be looking at solving piecewise functions. So we're going to be looking at two things today. We're going to be looking at transformation of functions and piecewise functions, okay? So let's take a look at our first problem. We have number 1. Use the graph of f of x, function f of x equals the absolute value of x below to obtain the graph of f of x equals the absolute value of x plus 3. So first they give us the original graph of absolute value of x, and then they want us to use this graph, the first graph, to graph the new transformation, which is the absolute value of x plus 3. So we're taking the absolute value of x and we're transforming it into the absolute value of x plus 3. So let's go ahead and take a look to see how we're going to do that. Now let's talk a little bit about transformation of function and what that really entails. So let's take a look at transformations, okay? So here we have transformations, meaning, transforming. When you transform something, it turns into something else, right? It either transforms to something bigger, smaller, goes up, down, and so forth. So when we have our function and we're adding a constant, so if we have our function f of x and we add a constant on the outside, we have what's called a vertical translation, meaning we're going to go up however many units our d is, the value for d is. If we have a function of x and we're subtracting a constant from it on the outside, then it's another vertical translation where we're going down d units. Then we have a function of x plus c, where we're adding a constant in the function, literally inside, and that will give us a horizontal shift, and that's going to move left if it's positive. If we have a function of x minus c, where the constant is inside of the function, we're also moving horizontal, but we're moving right. If we have a negative constant being multiplied by the function, we reflect it over the x-axis. If we have f of negative x, where the negative is inside the function, it's affecting the y, we're going to reflect it over the y-axis. Then here we have a constant being multiplied by a function. So when we have a constant multiplying a function, a coefficient multiplying the function, we do a vertical stretch if that constant is greater, if that coefficient is greater than 1, and we do a vertical compression if our coefficient is between 0 and 1. So if the coefficient is a decimal or a fraction, it's going to get wider. The graph is going to get wider. Then we have function of b of x, where if the coefficient was inside of the function, we would have a horizontal compression if b is greater than 1, or a horizontal stretch if b is between 0 and 1. So here we have some visuals, okay? Okay, so let's take a look at our function f of x, our quadratic function. Our constant a, our coefficient a on the outside indicates a reflection to x-axis. When we have a constant on the inside, it reflects a horizontal translation, and if we have a constant on the outside, it's a vertical. So here you can see if our original equation is f of x equal x squared, and if we're adding a constant in the inside of the function, it moves to the left. If we subtract a constant in a function, it moves to the right. And if we add a constant on the outside, it moves up or down. So let's take a look at our first problem. We have used the graph of f of x equals absolute value to transform it into obtain the graph of x absolute value of x plus 3. So when we have absolute value, our graph is always going to have a V shape. So whenever you see the absolute value bar, you know that your graph is going to have a V shape. That indicates that you have absolute value. So this is the original graph of the absolute value of x, and they want us to transform it. So let's take a look at what happened here. All they did was add a 3 to the absolute value of x. So all they did was added a constant. They added a constant to the outside of the absolute value of x. Now we know that since they're adding the constant on the outside, meaning it's on the outside of the absolute value, it's not in the inside of the absolute value, this is going to be a vertical translation, meaning you're going to be going up or down depending on the sign. Since we have a positive 3, we're going to be moving up 3 units. So let's take ahead and let's dissect that a little bit more. So here we have our original function, which is f of x equal absolute value of x, and then they want us to regraph, transform it into absolute value of x plus 3. Now, since this is on the outside, right, the plus 3 is on the outside of the function. We move up or down. Okay, so since it's plus 3, we're going to move up 3 units. So you're going to take every point on the absolute value of x graph and you're going to move it up 3 units. So again, since the plus 3 is on the outside, so for example, let's take a look at a few examples. If we have x plus 3 on the inside, here we would move left 3 units. Sorry. Okay, so let's say we have f of x equals x minus 3 on the inside. Do you notice how the plus 3 and the minus 3 is in the inside of the absolute value? So when it's inside of the function, we move left or right depending on the sign. If it's plus, you move left. If it's minus, you move right. Okay, now let's say we have it on the outside. Let's say we have the absolute value of x minus 3. Now, do you notice that now the minus 3 is on the outside of the absolute value? So when the constant is on the outside of the absolute value, you move up or down depending on the sign. Since we have a negative, a minus, we move down 3 units. So these are all different transformations. So it all depends on whether the constant is on the inside or the outside of your function. So if it's on the outside of your function, of your absolute value, you move up or down depending on the sign. If it's on the inside of your function, it's affecting the y-axis, meaning you're going to move left or right. If it's plus, you move left. If it's minus, you move right. Let's take a look at why. The reason why you move up or down when the constant is on the outside of the function is because here you're only affecting the x value. So the x-axis is vertical, meaning so I'm adding 3 to my x, right? Whatever my x is, I'm adding 3 to it. So meaning I'm changing my x value. My x-axis is changing. That's why I move up or down when I add or subtract a constant to the function, right? Because here, whatever I get for x, then I'm going to be adding 3. So I'm changing the x value. So I'm going to be changing on the x-axis. And the x-axis moves up or down. It's a vertical line. Now, when we have a constant in the inside, we're changing the y value, right? Because here, whatever x is, when I add 3, that changes my y, right? My y. So when the constant is on the inside, your y values are changing. That's why you're moving across the y-axis. That's why you move left or right, because the y-axis moves left or right. It's a horizontal shift. So now let's go ahead and graph them. Okay, so let's go to my graph, and we're going to first graph the absolute value of x. Okay, so here is my absolute value of x. It looks like a V shape. The vertex is at 0, 0. Now, let's see what happens when I add 3 to my absolute value of x. Let's see how the graph changes. So remember, I'm adding 3 to my x value, so my x-axis is going to change. Okay, so now let's take a look at what happened here. So here's our original function, absolute value of x. Then look what happens when I add 3 to the x values. This graph goes up 3 units. 1, 2, 3. Every point on this graph, every point on your original graph of absolute value of x goes up 3 units. So this point goes up 3 units. 1, 2, 3. Then we have, so here we move up 3 units, right? Then let's take another point. This point, right, over here, it moved up 3 units, right? 1, 2, 3. Then let's take another perfect point. This perfect point moved up 3 units, right? 1, 2, 3. So you're taking every point and you're moving it up 3 spaces. That's basically all you're doing, is you're moving every point up 3 spaces. And the reason why you're doing that is because you're adding 3 to the outside of the function. You're adding 3 to x. Every time you get a value for x, you're adding 3. So you're changing the x value. So you're moving across the x-axis, and the x-axis is a vertical line, so you're moving up and down. Now let's take a look and see what happens when let's say we moved on the outside. So let's say we have the absolute value of x, and we added 3 on the inside. Okay, so remember, the green graph represents my original graph of the absolute value of x. My blue graph represents my the graph of x, absolute value of x plus 3 on the outside, so we moved up 3 units. And then our red graph, the red graph represents our function h of x, where we added 3 in the inside, right? So since we added 3 in the inside, our graph moved left 3 spaces, right? So you can see here that this graph moved left 3 spaces. Okay? The reason why it moved left is because our function is absolute value of x plus 3. The 3 is inside the function, so I'm changing my y values here, meaning the y-axis is going to change, try and move left or right. Okay, so let's take a look at another one. Okay, so now we have number 2.